All right, this video is to help explain our last homework. This is the 10-11 homework on finding the nth term of a binomial expansion. So feel free to skip around and find the question that you're stuck on if you need some help. All right, question 1 says find the fourth term of x plus 1 to the 8th power. So remember, we're going to do our little shortcut here. Instead of finding all of the terms and just picking the fourth one, we're going to just jump right in and do our shortcuts here. So we're going to start with 8, and then a combination here. 8 minus 4 is 4, but we're going to add one more to that, so we get a 5. I'm assuming this is going to be a plus b, and then I'll plug my stuff in afterwards. I would really recommend that you do that, especially as we get to the other questions. Don't try to substitute things right away. So we have a, it's going to match this number here, it's going to match the exponent. And then these two exponents for a and b need to add up to this big exponent. So this is already a 5, this one needs to be a 3. Right? So then we can either use the calculator to find this. I'm listed out by hand. I have 8 times 7 times 6 times 5 times 4. I have 5 of these little numbers, since this is a 5. And then I have divided by 5 times 4 times 3 times 2 times 1. Right? Now we notice some things actually cancel out on the top and the bottom. I have C of 5 on the top, 4 on the top and bottom there. Then actually 3 times 2 times 1, that whole thing is really a 6. That cancels out with that 6. So we really just have 8 times 7, which is going to give us 56. But again, you're welcome to use the calculator to figure these out. Then I have a to the 5th and b to the 3rd. A is actually not A. A is actually our first part in that binomial, so it's actually going to be x, which really doesn't change it too much. And then b is our second term in the binomial, so that's actually just positive 1. Again, not changing it too much. So if I actually do the exponents and multiply it together, I will just get 56 x to the 5th would be the fourth term in that expanded binomial. All right, question 2. Find the third term of 2x minus 5 raised to the 5th power. So we're going to do 5c, and then we're going to do 5 minus the term we want. So 5 minus 3 is 2, and add one more to that, so 3. Then our a exponent is going to match this number. Our b exponent needs to add with this one to make it a total of 5. So that's why it's to the 2nd power. Okay. Again, all of these I'm assuming it's just a plus b, and we'll substitute afterwards. So 5 times 4 times 3 divided by 3 times 2 times 1 is what we would get with our combination stuff. I'm going to cancel, or I have 20 divided by 2, that's really 10. So my coefficient here is going to start out being a 10. And now I'm going to substitute my a and my b stuff. Okay? So a is the first term, is actually 2x. So make sure both the 2 and the x are in parentheses, and then you cube each of those. And then the b is the negative 5. That negative is also very important to include, but included in parentheses. So now I'm going to take care of the order of operations, so as to do the exponents, then we'll do the multiplication to condense it into just one final term. So I have 10 times 2 cubed is 8, and then x cubed is x cubed. And then negative 5 times itself. Negative 5 times negative 5 is positive 25. Okay? So we're actually going to multiply the 10, 8, and the 25 all together to get my final coefficient. I think that's just 2,000. Then we have x to the 3rd. Okay. Question 3. Find the 7th term of 3y minus 2z, that quantity to the 6th power. So instead of expanding it all the way out and just finding what the 7th term is by counting, we're just going to find the 7th term right away. So we're going to start with this exponent, 6, c, and then we're going to do 6 minus the term we're looking for. 6 minus 7, it gives us a negative 1. We're going to actually add 1 back to that, so we got a 0 here. My a exponent is going to match this number, and my b exponent, these need to add together to make 6, so this one has to be 6. Right? If I have 6 items and I'm choosing 0 of them, there's only one way to do that, and that's just to not choose any of them. All right, now I'll do my substitution. A is going to be 3y. So I have 3y to the 0 power. And b is negative 2z. Again, very important, you include that negative in the parenthesis and then raise it to the 6th power. So we need to do the exponents, then the multiplication. 1, anything with a 0 power is a 1, so that's really 1 times 1, times negative 2 to the 6th, should give us a positive 64. And then we have z to the 6th also, so really 64 z to the 6th. Right. And if you think about it, this would actually be, if this is an exponent of a 6, that means there are actually 7 terms. If we're looking for the 7th term, this is actually the last one. This is a z. Hopefully you can tell, instead of it being like a 2. All right. Moving on to question 4. What is the third term of 2x plus 1 over 4x, all of that to the 7th power? This is actually a question from the textbook, if you wanted to reference that. So same thing as before, I'm going to, especially on this one, assume that it's a plus b to the 7th, instead of worrying about the fractions and exponents, variables and stuff. So we're going to start with our exponent of 7, c, and then I'm going to do 7 minus, I want the third term, so 7 minus 3 is 4, and 4 plus 1 is 5. Okay. And I have a to the same exponent as that, and then my b exponent, these need to add together to get 7, so that's going to become a 2. So again, I have 7 things, I'm going to choose 5 of them, and the order doesn't matter, so that's going to give us 21 for the coefficient part. Now in the a spot, the a spot is the first term in the binomial. That's going to be 2x. And our b spot is the second term, which is this fraction, 1 over 4x. All that's squared. So the next thing we do is the exponents. Copy down the 21. And then I have 2 to the 5th, but also x's to the 5th. So 2 to the 5th is 32. Now I need to do the other one. So I have 1/4 squared and also the x squared. So 1 squared on the top would give us a 1. 4 squared on the bottom is 16, and then x squared on the bottom is x squared. So we're going to multiply this together. I'm going to multiply these two the coefficients first. And I get 672. And then I'm going to actually divide it by 16 because I simplify that fraction there. So we get 42, the coefficient. Now I have the variable as x to the 5th over x to the 2nd. Remember, when we have variables that are kind of being divided, technically here, we're going to subtract the fractions and get x to the 3rd. Okay. So you can't see x to the 3rd is there, I promise. Okay. Next question, there's no c in it, we just have a and b. This is just back to the previous lesson, 10-10. Expand each binomial. So we're going to use the Pascal's triangle to do this. We want all of the terms, not just one particular term. So it's going to be fastest for us to write it all out. And you might need some another piece of paper, possibly for this one. Hopefully giving you extra room by taking out that third question C right there. All right, so first one. 3x plus 1, all of that is to the 3rd power. So this is going to be from our Pascal's triangle, which you can reference. It's going to be our 3rd row here. So our coefficients are 1, 3, 3, 1. So I'm going to write those down first. 1, 3, 3, 1. Then my variables, again, I'm going to assume this is a plus b to the 3rd, and I'll do the substitution at the end. My variable for a is the highest it can be on the left, and it goes down. A to the 0, we don't really need to write that. And my b exponents are going to reverse that, and they also add together with the a exponents to make 3 altogether. And I'll just add some plus signs in here. Okay? So really we don't need this a to the 0. We don't need this b to the 0. So now we're going to do our substitution. So anytime there's an a, that's actually 3x. So I have 1 times 3x in parentheses and then cubed plus 3 times 3x parentheses squared. And then each time I see a b, b is 1. So this term I'll have a 1 to the first power. Our original 3, and then in our a spot is going to be the 3x, because that's from the first part in our parenthesis. And then my b squared. The last term is 1 times our b number cubed. So again, we're just going to do the exponent for each of these. Try to simplify each so that they all become just one term each. So 3 to the third, we get 27 x to the third here. Then again, think about your order of operations. We have to do this 3 squared first before we can multiply it by this 3. In this particular case, it's really not going to make a difference, but if the numbers were different, it would. So 3 squared is 9, and then 9 times 3 is going to give us also 27 x squared. I would multiply it by this one too, but multiplying by 1 doesn't really do a whole lot. Our next term, this exponent, again, really doesn't change anything since that's just a 1. This exponent doesn't change anything, so I'm just multiplying 3 times 3x, so we get 9x. And the final term is just a 1. Okay. Now, again, you could multiply this out by having 3x plus 1 times 3x plus 1 times 3x plus 1. And just pick 2 at a time, maybe focus on these 2, multiply it together, get a trinomial, and then multiply it by this one, and that can get you our answer as well. But when our exponents get really big, that's why we kind of like this Pascal's triangle method instead. Okay. Question B, same thing. We have y minus 2x, all of that is to the 6th power. So I'm going to list out my 6th row of the Pascal's triangle, so that should start with a 1 and then a 6. 1, 6, 15, 20, 15, 6, and a 1. I'm going to take up this whole space here. 1, 6, 15, 20, 15, 6, 1. Oh boy. That's why I took out that. There was a third question there, but there's just no room for it. And you practiced that the last lesson as well. So our variables, again, I'm assuming it's just a plus b for now. Our a exponent is going to start out at 6 and go down as we go to the left. And then our b is going to reverse that. So we have b to the 6th, b to the 5, b to the 4, b to the 3, so on. And then we don't really need 1 on the end. I'll squeeze some plus signs in here to try to separate my terms. Okay. So now we're just doing the substitution. The a is the y, because that's in the front spot. And then b is going to become negative 2x. So we're just going to substitute those things where we see them. So we have y to the 6th, y to the 5th times b to the 1st. This might need a couple of lines on your paper to plug this all in. Y to the 4th, negative 2x squared. I would really recommend you don't try to do the exponent at the same time. So you're more likely to make mistakes there. And we have y to the 3rd times negative 2x all to the 3rd. So that's, I'm through here right now. I'm going to do this 15 one on the next row. 15a squared, so y squared, and then times b to the 4th, so negative 2x to the 4th. And I got 2 left. Next is 6 times a to the 1st times b to the 5th power. And our last term here, 1 times b to the 6th power. So we're kind of focusing on these 2 rows here and simplifying that. So our order of operations, we have to do the exponent first, and then we will do the multiplication to simplify each term. This one just becomes y to the 6th. This one, so I have y to the 5th, that's not really anything different. This is also not really anything different, so it's really just 6 times negative 2. So I'm actually write negative 2 And I'm just going to put it in alphabetical order. You can put plus, or you could put plus and the negative. It's fine. Next term here we have y to the fourth. That's really the same. Negative 2 squared becomes 4. So that 4 times 15. That's going to give me 60. And for my variables, I have x squared and then y to the fourth. Again, I'm just going in alphabetical order, but you can have the variables switched around. That's really not a big deal. This one over here, y to the third is y to the third. Negative 2x cubed, I have to do negative 2 cubed, which actually makes negative 8. So negative 8 times 20. So that's negative 160. And our variables are going to be x to the third and y to the third. So that gets me through this row, simplifying it. Jumping down here, simplifying this part. 15. Oops, I don't really need, I'm not going to write that. Let's see. So y squared is just y squared, negative 2x to the fourth. So negative 2 to the fourth means negative 2 times itself 4 times. It's going to give us positive 16. So positive 16 times positive 15 is 240. Then my variable is x is to the fourth power, and y is to the second power. We got 2 more terms to go. Alright, so next one we got y to the first, that's fine. Negative 2 to the fifth, that's going to give us negative 32 times the 6, that's in front, that's negative 192. You might see how our symbols are alternating positive, negative, positive, negative, positive, negative. And that's because whether this negative is raised to a positive or an even or an odd power changes, you know, what it ends up becoming. Last one. Oops, that's not what I meant to do. 2 to the 6th, we'll get positive 64x to the 6th. So this whole entire thing here is that expanded binomial raised to the 6th power. Alright, the back page we have just some kind of random old stuff. Some to throw it in, help refresh your memory here as we wrap up the year. Question 6, find the equation of a line that is perpendicular to y equals 1/2 x minus 3 passes through the point 10, 14. So perpendicular means it's going to have an opposite and reciprocal slope, or a negative reciprocal for the slope. Slope is currently 1/2, so the reciprocal of that would be 2 over 1, and then the negative reciprocal of that is a negative 2 over 1. So we need to have a slope of that. It needs to pass through this point. X is 10 and y is 14. So all I'm going to do is substitute all of these things into the equation of a line, and we'll solve for the y-intercept because we know that part is probably not going to be the same because it's going through this other point here. So 14 equals our slope, our perpendicular, so negative reciprocal slope, and then times our x coordinate. We're going to solve for that y-intercept. So if I add 20, I get 34 is my y-intercept. So you know the slope, we know the y-intercept. Just put it all together. Negative 2x plus 34. Okay. Question 7 and 8 is a little review on logs, which was from a little bit of the first semester right at the end and then the beginning of the second semester. So this question 7 says simplify into one logarithm. We need to remember these different properties of logs. So one is called the power property, which is where we move this number from the front up to the exponent, and we actually do it for both things inside the parentheses. So I'm going to start with that first. So this is going to become a log of 5 to the third power, which is 125, and also x to the third power. This next log doesn't have anything in the front, so there's no exponent to move back on top of it. Minus, I'm going to square both of these things. So 12 squared is 144, and then x squared is x squared. So that was called the power property. We used that kind of in reverse earlier in this chapter to solve for the number of terms when it was geometric. You had to add a log in on both sides, and then you can remove the exponent down. So it's just this in reverse. Now the other two properties are, one's called the product property, which is if you are adding logs, you're really going to multiply the insides together. So 125 times 4 is 500, and I just have the x to the third still. Right. We're going to go left to right when we do these, just like you normally solve things left to right in math. Then this part is subtraction. This is called the quotient property. So when you're subtracting logs, you're going to actually divide the inside stuff. There's still a log there, but I'm going to make this into a fraction. Okay? And I know for sure we can simplify the variables. X to the third over x squared would leave us with x to the first on the top. And I'm going to try to simplify that 500 over 144 just to a smaller fraction. And that looks like we can simplify, if we divided both of them by 4, we get 125 over 36, and I'm going to put the x on the top because it would be x to the first power. So we simplified it just into one logarithm here. So that's just a little bit of a review of some old stuff to keep in your mind. Remember, we even learned logs this year. Question 8. Now this time we're going to be solving an equation with logs in it. We're using the properties we did in the previous problem to solve this. So we need to combine this one side here into just one log base 9 with one thing. So we're going to use that product property and multiply these inner things together. It's still going to say log base 9. Now it'll say x squared minus 8x. And the other side was still 1. Okay. So from here we have log only on one side, so we can't just take away this log. We also can't just add in log onto one side. We have to either add it to both or take it away from both. So we're going to change this into the exponential format, which I also refer to as going around the world. So 9 to the first power equals x squared minus 8x. Right? Logs and exponentials are inverses, so if we switch this around, it gets that log out of there. Now this is a quadratic. I'm going to get everything to one side. So I have 0 equals this, and we'll just factor it. So up to here, x times x would give me x squared. Things that multiply to 9, that could multiply to 8. Probably going to be 9 and 1 versus 3 and 3. And thinking about the negative signs, I want it to add up to negative 8, so I'm going to have it be negative 9 plus 1. When I set each of these equal to 0 and solve it, I'll get negative 1. If I set this one equal to 0, I get positive 9. In log equations, and any equation in general, it's really important to check your answer. So very easily you can just plug these back in. When we are working with logs, if you take log of a negative number, that's not allowed. So if you're plugging in these x's and it gets you a negative inside here, like this one would, and it would also with this part too, that's not going to be a real solution. If I plug in 9, I can take log of a 9 and log of 1. That's acceptable. Right, so we only have one solution actually, even though we got 2 different answers. So just make sure you check, plug it in with all kinds of equations that you solve. All right, last question here, number 9. This is a review of things we've done earlier in this chapter. Find the sum of each type of series. So question A is the summation notation, saying find the sum from the 1st through the 16th number. And here's our little formula. This is in first term form. Again, that n minus 1 needs to be there. A lot of people are still not sure when it's in first term form or not. So it needs to have n minus 1. If it just has an n in the exponent, it's not in first term form. Since it is in the first term form, I know the first term is 5, and I know the multiplier is 1.25. So to find the sum of geometric, I'm going to call that R because that's what we reference that as. To find the sum of a geometric, we need the first term, 5, times the multiplier, 1.25, raised to the n term, or however many terms there are. From 1 through 16, there's going to be 16 terms. Then we're going to subtract the first term. And then we're going to divide by 1, or the multiplier, minus 1. 1.25 minus 1. Okay? So I would just type the top part in on your calculator. make sure you get out of that exponent when you subtract the 5. So I get around 172.6-ish for the top, and I'm just going to divide that, and it's going to keep that same answer. I know the bottom is really 0.25, so if I just divide by that, we get 690.54-ish. Obviously, we're going to have some decimals going on there. And if I were to try to change that to a fraction, I don't think it changes into a fraction. So we could have that. We can add a couple more decimal places. Didn't really say for this particular question, so feel free. I just wouldn't round it to 691. I wouldn't round it up all the way like that. Okay, that's for geometric. Question B says, find the sum of an arithmetic series where n, which means the number of terms, there's 18 terms. This means the first term is 72, and D stands for the change or the common difference is 9. So for an arithmetic series, to find the sum, we need the first term, which is 72, plus the last term, which we don't have that information quite yet, times the number of terms divided by 2. So we have to do a little bit of digging to find this last term. We know there's 18 terms. If we can figure out what the 18th term is, that would be the same as the last term. So we're going to use that first term form, 72 plus it's adding 9 each time. That's what that D represents, and times n minus 1. If I plug in n as 18, that will tell me the 18th term, which happens to be the last term, right? So just calculating that however you want to do it. 72 plus 9 times 17 is 225, is the 18th term or the last term. So I'm just going to replace that up here and write 225 in there. And we'll just type this in our calculator. Again, making sure that this is in parentheses, or you do that addition actually first, and then this is in a second set of parentheses. 72 plus 225, and then I'm going to multiply that by, I know that second part's really 9. So it looks like our sum is 2,673 for this one. Whoops. So much smaller here. All right. Again, reach out if you have any questions on things. Still, we got one final check-in quiz this week. So keep up the great work. You guys have worked really hard during this trying time. So again, reach out if you still have questions, and you're almost there.